Hello, everyone. Thank you for joining us for episode 1 in the Bringing Your Containers to Azure series. This episode is Deploying Your Containers with Azure Container Instances. Before we start, I have a few quick things to go over. Please take a moment to read our code of conduct. We ask that you be kind and respectful to everyone, including our speakers. We want the reactors to be a place everyone feels welcome. Please ask questions using the live YouTube or Learn TV chat. In the chat, we'll also be sharing some links to the Reactor meetup page and monthly newsletter if you're interested in checking out what other sessions we have coming up. If you haven't already, please check in to today's event using aka.ms/reactor check-in with event ID 14313. By checking in, you will receive links to the content that go along with today's session. Today's session will also be added to our Reactor YouTube page in 24 to 48 hours. And finally, I will share a link to our Reactor survey. If you have a few minutes, we greatly appreciate your feedback. And I will now pass it over to Sam.
All right. Hello, everyone. I'm Sam Wronski. I'm a regional cloud advocate for the San Francisco region. And today we're going to be looking at container instances, Azure Container Instances, and how you can bring containers to Azure using Azure Container Instances. What this lets you do is run Windows or Linux containers inside of Azure in a relatively simple way without having to set up very complex infrastructure like you might have to do with Kubernetes. So it's sort of an easier and more accessible way to do that without having to set up a full platform for your services. So we're going to be kind of walking through and deploying a sample app that we've already built in a previous episode. This one specifically behind me. So this is just a really basic .NET app that says hello world when you go to it. And so what we're going to be doing is deploying that to Azure and getting this into a public space so that anybody running this can actually query our app and see what's there. So we're going to kind of take this in steps and walk through a few different things to do to make this happen. There's a few things that get a little bit more complicated, so we're going to get to those when we get there. But first, we're just going to kind of take a look at deploying a resource as quickly as we can. So we're actually going to deploy an existing image that is already public, so we don't need to go through all of the extra steps that we might otherwise. So to do that, first, we're going to create an Azure resource group. I'm going to be using one resource group for this entire demo, and that is specifically so that we can easily clean it up afterwards. So we can delete the resource group and just get everything back where it was at the beginning. So we're going to create this in SQS, and we're just going to call it our demo. And so that will create a resource group inside of Azure for us. And then what we want to do is actually deploy a container. So I already have sort of the commands here for this. So we're going to kind of just copy and paste a little bit just to make this go a little bit faster, because this is more to show what this actually can do rather than anything else. So we're going to set up a resource name, give it az container create is the command to actually create a container inside of Azure, create a container instance. We give it the resource group we want to use, which is our new demo one that we just created. And then we need to give it a name. There we go. Give it a name. And without the space, there we go. We'll just call this our demo container. And let's give it an image. So I'm going to actually copy one. This needs to be a public image that you have access to, because otherwise your container resource is not going to have access to it. It's not going to know how to pull this. You can use anything you want, though, as long as it's publicly accessible. I'm using one of our Hello World demo containers. But again, you can pull whatever you would like. And then we're going to give it a DNS name label. And we're going to see a few interesting issues with that. I'm going to say ACI demo, Azure Container Instances -demo. This probably is going to fail, but we'll get to that in just a second. And then I'm going to expose the port. So we're saying we want to hit port 80 on this container. And so if we run this, I'm anticipating we're going to hit an error that the DNS is not unique, not available. And so we're just going to call this the SAM ACI demo. What we should see here after a few seconds is we actually get our container up and running in Azure. This does take a few seconds to kind of pull the container and set it up and get it running. But the useful thing with containers, we had kind of touched on this previously, containers are a lot more lightweight than something like a VM, which typically involves coffee breaks after you start trying to set them up. These run typically much, much faster. And so you can actually run this and get something relatively quickly that is running in the cloud and accessible to pretty much everybody. And so this should create a public application like this that we can just access. Let's make this a little bit bigger so you can actually see what's going on. And so the things that we kind of care about right now are this IP address. This is telling us where our container is now. So our DNS name label got incorporated into the FQDN, which stands for Fully Qualified Domain Name, which is the accessible place on the internet that we can actually go and find this thing. So let's do that quick. And there we go. There is our container instance running out in Azure relatively quickly. Took 5-ish minutes. And so that is what we're going to be doing, but we're going to be bringing our personal container. This gets a little bit more complicated. So we're going to be kind of stepping through how to do all of that. So let's get started. First off, let's delete this container, delete. And we called this the demo. This was a interesting thing. I should have put notes for this command. Anyway, we're going to call it demo. So that's just going to pull down the container we just created. We don't need that constantly running there. Instead, what we're going to be doing is sort of deploying our own thing. The problem is that the image that we created when we ran through and created this .NET app is local to our machine. It only exists on my computer. And so if we try to deploy this to Azure, it's not going to know what we're talking about because it doesn't actually know anything on our own machine. That isn't what it does. And so we're going to actually be figuring out how to deploy this into a container registry, which is going to store these images. And then from those container registry, we're going to pull that into our container instances and run it that way. So that's sort of the arc that we're trying to go on here. So first, we actually need to create that container registry. Container registries in Azure store a whole bunch of containers. In this case, it's going to be a private container registry. So that means that nobody else is going to be able to access this without a set of keys. So we're going to need some sort of security credentials in order to actually access these. This is useful if you have like corporate things, like you're actually trying to run applications that you don't just have an open source that anybody can run in a public registry. So let's create this. The commands for this are ACR, so AZ ACR, and then create. Let's get this to the top. ACR create. Our resource group is demo. And then the name is going to be the name of our registry. So we'll just call this our registry. That's probably not a great name, but we'll go with it. And then we're going to set it as the basic SKU. That controls the size of it, the amount of space that you're allowed to use. We need a double dash there. There we go. Cool. All right, so this is going to actually set up our container registry, and that's actually going to get us name needs to be unique. So let's do something a little bit less like that. ACR. Cool. So we're going to create this container registry. Can't have spaces. All right. Note to self: remember naming when you're writing your notes, and don't just make it up. Anyway, cool. There we go. We have our container registry. This is going to actually be something that we're going to use to actually upload our images to and work with. The problem is it's also in the cloud. We don't have access to this. So what we want to do is actually log into this so we can reference this locally. Another thing we want to keep in mind is this string, the login server. This is going to be what we're going to use when we're tagging and labeling our containers or our images. So I'm just going to copy that, and then we're going to log in to the container registry. So login name and we need to provide the registry name. When we're using ACR commands, the registry name, the name you provide here, is not the full login server. It's just the name we use. So Sam ACI demo. I recommend not including my name in whatever demo you're doing, but this should be enough for us to actually log in here and get access. So once we see login succeeded, that means that Docker on our local machine now is authenticated with this registry. It means that when we try to actually upload images here, it should work. And if it doesn't, then we're in trouble. So what we want to do now is we already have an image built. It already exists on our machine, but we want to get it into this container registry. So what we're going to do is look at all of the images. So if you just run Docker images, it's going to list a whole bunch of things. What we care about is just the one that we actually want. So in my case, it's dockerized.net. So we are going to look at that name right here and use that as sort of the name that we're going to do. Then we want to tag our image. Tags can be duplicates. You can see I've done this demo before. So in this case, it's the same image ID. It just has a different tag. So we're going to be tagging this again with our container registry and giving it some name. So Docker tag, and then the name of the first thing we had, so dockerized.net. And then we want the registry name. This time it should be the full thing. And then whatever the name we want to use for that image. So we'll just keep the same thing. And then the version. So we're going to label this v1. Typically, you don't want to reuse latest over and over. It tends to create issues because now you can't go back to whatever you had uploaded previously. So we're going to upload v1 here. And that tags it. So if we Docker images again, we should now see we have a new tagged image right here that references that new image. It's the same thing, has the same ID, but it's got a new name. And so what we're going to be doing is actually pushing that up into the registry. So let's do that. Did I not? Okay, I didn't do the name. So we're going to do a Docker push and then this. There we go. Cool. And so this is actually going to be pushing it up to Azure for us. So all we've done is done Docker push and then given it the name. This will fail if you haven't authenticated with Docker already. But what this is doing is now uploading this into our cloud. So once that's finished, we'll get a SHA of what we uploaded and get our prompt back. We can actually go and check out what is there now. We refresh this and look. At our resource groups. There we go. We have our demo. And if we go in here and look at our container registry, we should be able to see under the repositories, our new dockerized.net image show up there. And so this actually shows you your image that has been uploaded. You can actually see the versions that we uploaded, in this case, just v1. But this is a way to kind of browse and view what is actually up there and what is in your thing. If you want to do this from the command line, that looks like this. So ACR repository list, and then the name of the repository we want to look at, which is Sam ACI demo, and then the output to a table. If you don't do output table, it's going to give you a much more condensed version. So I found this is just nicer, but this actually lists the results here. So we actually get the names of the images that we've uploaded. And that's that. So we now have our image up in the cloud and we should just be able to run it. That's sort of what we're trying to get to. Unfortunately, it gets a little bit more complicated than that. And so we're going to kind of tinker with this a little bit. The cool thing is even though we've tagged that and published it into the cloud, it still works locally. So if we want to rerun everything that we were doing, let's publish this to port 5000 and make it interactive. And do this, or just grab this again. And v1 should just be able to run our container locally using the one that we published up to the cloud. And so what this means is we kind of have the same images running. Again, this isn't actually that unique. This isn't something that crazy, but it's a really useful thing to be able to do. Is now we have sort of a unique reference that we can use in the cloud and locally. So you don't have to rely on like two different version names, one in the cloud and one locally. This thing is just published. And so we can kind of pull this down if we open this on a different computer and get the same image. And the advantage there is now we have this reproducible system or this reproducible container that we can just keep recreating in different environments and getting the same results. Just to demo what this is supposed to say, localhost, we get hello world. The demo is not exactly that interesting. It's intended to be low code, so we get a quick demo. But there we go. That is our application just running locally. Now we want to get it running in Azure. And so that is sort of where the complications come in. So what we're going to do is try to create a container, just like we did previously, further up here. When we were creating our container, that's the container registry. Anyway, when we were creating our container, we ran this and gave it the container name to run and sent it a few parameters, and it just ran. That's not going to work here anymore. Unfortunately, it's now private, right? So we've created this private image reference, and it's intended to be internal to my resources. So something that I own, not something that is public to everybody. And so we can't really do this. If I do our container create resource group and just call it the demo container again and give it our image, we can use the same one that we were using locally. Now we're just using it in the cloud. We're going to give it a DNS label. Again, this is used to create that fully qualified domain name. So this needs to be relatively unique. Otherwise, you're going to run into issues. And so we'll just call this Sam Container Demo. This is, for me, this is a demo, so the name doesn't really matter. You probably want to use something that makes a little bit more sense. And then we're just going to point it at port 80 and go and see what happens. And it's going to ask us for an image registry username, which we do not have. So there is what's trying to happen is Azure is trying to pull the container image to spin up this thing, and it doesn't know how to do that. And so what we need to do is actually create some way for our container registry or for our container instances to access the container registry, to pull the image and actually be able to create the thing. And so what we're going to do is kind of take a detour through permissions and authentication, which is somewhat fun. And so we're going to be taking a look at creating a service account. So service accounts give you, they define specific permissions that a service account has. And so in this case, we need to give it permission to pull from our container registry. There's different things that you can give permissions to do in the container registry. There's the ability to pull, which just means that you can read what is pushed into that registry. There's the ability to push, which means you can upload new copies of a version, and you can also pull. So you can push new images like we just did, or you can pull them. And then there's an owner, which can actually assign roles, so can actually allow more people to pull or push from that repository or that container registry. All we need for our container instance to run is access to the ability to pull the image. So that's what we're going to be focusing on here. There is a set of scripts that I found very useful for this here. And we're going to be kind of using a version of those. But this is out on the Microsoft Docs stuff, if you would like to access that. And so what we're going to do is give it a registry name. My notes are a little bit not the same as this, so we're going to update them a little bit. Give it the registry name, and I'm going to be storing these in variables. The advantage of storing these in variables is that we do not print out the password that we're going to get from the service account or the username. So we're keeping that relatively private so it doesn't leak out and show everybody how to access this. That's typically not what you want with this. So then we're going to save our registry ID, which is got from grabbing the name here. So ACR is again Azure Container Registry, and we want to show the name. Or not. What? This should work. I'm not sure what's going on there. That's weird. Is here show name? Have I spelled that correctly? Yes. Oh. My notes are missing something. Interesting. Okay. We actually need the name of the registry. Just adding name isn't going to do anything. So let's do this. Again, we're using ACR here, so that's the container registry's name. In this case, that is SAM ACI demo. The same thing in our image right here. We're pulling that in and showing the name there. And so that's going to give us this, the same thing we got when we created it. But now we want to store that in a variable. What do we call this? ACI demo. There. Okay. So that ends up getting stored into our registry ID. And then we need a registry. None of this. I'm missing parts. Anyway, let's grab that. Now we want to query the specific ID. So this long string here is sort of what we're looking for. That's what we want to store in this. So we're going to grab that ID. So query the ID to specify that we want to pull out the ID from this JSON blob. And we're going to output this as a TSV. And so this should get us something a little bit nicer so we can just take a look at what that was. And we get the same string. We just don't have to worry about all the JSON stuff or any of that. All we get is the string. And then what we want to do is actually create the service account. All this is doing is kind of giving us some helper variables so that we can actually access this and do a little bit more work to kind of create what we're trying to do. So what we're going to do is save the service principal password. It's going to be returned from creating the service principal. And that's done with the Azure Active Directory service principal create for RBAC. And we want to give it the name of our service principal, which is, have we already created that? We have not. So let's do service principal name, ACR demo poll. And then we need to set the scopes for what we're trying to do. And so this scopes should map to our container registry. So we're assigning permissions specifically for the container registry for this thing. And so we need to assign that by just grabbing that string that we stored. You can just copy and paste this if you would prefer, but I think using variables is a little bit nicer. So that's what we're going to be doing here. And then we need to figure out what role it is. So the three roles are ACR pull, which is Azure Container Registry pull. That gives you permission to pull images. And then push is the opposite one. So ACR push is going to allow you to push and pull. And then the other one is owner. You probably don't want to give this the owner permission. If you're intending to do some automation and have your ability to push new images and updated images, having push ability might make sense. But in this case, we're just looking for something that our container registry can actually run from this. So we're going to ACR pull this or give it the role to pull. And then we want to pull the password out of this creation. So we're just like we queried the ID from this JSON blob, we're querying the password from what is returned when we create this service principal. And then the output is again going to be a TSV. And that is a really long string of a whole bunch of things. But basically all we're doing is trying to create a new service principal that we can use to pull images from a specific container registry. And that's sort of what is going on here. We have these scopes to define where we're going to be able to pull things from. The role is going to allow us to actually pull those things. And the query for the password is actually going to give us the password back so we can actually continue to access this after we've created it. And so if we run this, it might take a bit. There we go. And then we can grab the registry ID. So this is actually going to be what we're going to use to, the app ID. The app ID is what we're going to be using as the username for this service principal. So if we create a service principal with an app ID equal to Azure Active Directory, the service principal, and list that. And then we just want to display the name of our service principal, which we called ACR demo pull. And I want to query the app ID with another TSV output. So we're going to grab the ID of this service principal and use that. And so if we pull this, we should get something back. And that will allow us, that will give us both the password in this variable and the app ID that we can use to actually access our container registry. And that's the information we need to actually be able to use this and interact with this in a way that Azure understands so that it can actually pull our image. So that is, I think, everything we need. There are a few extra parameters that get added onto our container creation process because we want to actually integrate with that registry. And so let's just go at it again. So we want to create a new container. And this is going to be relatively similar to what we were doing previously. So create a new resource group. We'll call it the demo. And we want a new name, which is just going to be our demo container again, with the image that we were using previously, which is up here somewhere. So you grab our demo image, the one that has the fully qualified name pointing out to our Azure Container Registry. And so if we create that image, then we should be able to start specifying some of the specific things that actually allow us to access this now. So we need to reuse both of those demo things. So we are going to add a registry username with our service principal app ID and the registry password with our service principal password. There we go. So that is actually going to be the two things that are sort of required, these two bits. Registry username and the registry password are what is needed to actually be able to access this. So that tells our container instance how to actually go and pull that from our container registry. And then we're just doing the DNS name again and the ports so we can actually access this. So if we use ACI demo and ports, let's just use 80, and we should be able to run this. I am expecting this to fail a little bit. In the DNS name can't be used. It's not available again. So what we need to do is actually give it something unique. This is a error that I ran into a bunch of times when I was first learning this. So I'm kind of intentionally injecting it in here just to kind of show that it happens. It's not a big deal. You just need a new name. So we'll call it the SAM ACI demo, and that should be available. You probably want to use something that's a little bit more unique, even adding some like random strings to the end so that it's unique. But in this case, we're just throwing strings at it. And so that should run our container now. And if this works, what we'll end up with is our container that was running the hello world.net application actually out in Azure running everything that we wanted. And so this should actually give us a containerized.NET application actually out in the world. And that's sort of what you're trying to do here. I've gone through this fairly quickly. I'm scanning for questions, and I do not see any. But yeah, that is most of it. Once this finishes, there's a few other things we can kind of talk about. And then that is that. But this is intentionally designed as sort of a way to quickly get something up and running in Azure. The advantage of container instances over something like Kubernetes is it doesn't have as much flexibility, which sounds odd. But the advantage there is it requires less configuration. You don't need to know as much about it. In this case, we're just saying run this container and giving it some resource restrictions. In this case, I believe it's 1 CPU and 1.5 gigs of memory. And so if we go and do that, we have our container running. We have the fully qualified domain name. And so we should just be able to go out there and actually see hello world running out there. And anybody should be able to actually hit this. So that is getting it all the way out into Azure and actually running our application out in the real world. So there's a few other things that we kind of want to cover here. This is getting it basically up and running. We covered a lot of things. There's a lot of other configuration that you can do to kind of scale this up or run Windows containers if that's what you would like. So if you need IIS, for example, or Active Directory, I don't know if Active Directory, I can't actually say that. I've never tried it. But if you need a Windows container or a Linux container, Container Instances supports that. And so here we have the OS type. In this case, it's Linux because we're creating Linux containers. But that's that. The other thing, if you want to grab the logs for this, so there's a number of ways you can do monitoring of your service. This is probably the easiest way, maybe not the best way. We'll maybe get to that in a future video. But in this case, we want to actually start running our logs here. So AZ container logs is going to go and look up the logs for that container. So in this case, group demo name and give it the name of the container. And this should list the logs for that. So in this case, we just have the default .NET stuff showing us that we're now hosting on port 80 and how to set it all down. We have our production. This is, again, a demo app, so there isn't too many logs, but it is a way to kind of pull those logs out. This is useful, especially if you have a console application. So in this case, we're hosting ASP.NET, so we can actually run a website. But that isn't the only thing you can do here. If you want to deploy a whole bunch of console applications, for example, that will work too. But because you don't have any other way to kind of see the output, looking at logs can be a good way to do that. It can be a way for you to actually go and grab the information that you need. And so there is that. And then what else? If you need to delete these things, we kind of talked about this already, but you can do AZ container delete with the resource group, demo and demo container. And this is actually going to go and remove that thing. If you're trying to delete the whole thing, we can just drop the resource group and AZ group delete. What else? I'm missing something. I think that's most of it. What is the difference between running a .NET application as a Windows container or a Linux container? So there's two different things between when you're talking about running something as a Linux container versus a Windows container. Containers kind of share a core kernel. And so the difference is going to be your operating system environment. If you're running a Windows container, there are a set of container or Windows runtimes that you would use. Typically, I've seen this done with like IIS, for example. So if you have a dependency on IIS and you have some like ASP.NET 4 application on IIS, and you still need access to IIS, and you don't want to migrate into Linux, or you just like where it is, you can use that. Or if you need access to specific Windows capabilities, you might use a Windows container. They're not compatible with one another, so you can't just deploy this container into a Windows environment and expect it to work. That isn't really going to happen. But if you want to play around with those and you have a Windows PC, and Docker for desktop, you can go into the Docker image down here, if that actually does its thing. There we go. And so I like to just right-click this, and there's a switch to Windows containers thing. I am not going to click that because that's going to break things. But that is sort of what happens with this. For whatever reason, my computer doesn't like opening the context menu there. But there is a menu, if you click that, that is actually going to give you an option to switch between them. I would recommend just checking it out if you have access to a Windows computer and giving it a shot. I think Windows containers are less common, but they're still pretty cool, especially if you need specific Windows features, because that's how you would access them. Yeah, I think that's that. The complete differences is more, and some of it I don't necessarily know, but there are some good docs that I might be able to find if we have some time at the end. Any advantage, disadvantage to using ACI versus app service web app for containers? I'm not sure. I'm less familiar with app services, and so we're taking a look at Azure Container Instances sort of as a stepping stone into Kubernetes, because that's sort of where I'm more familiar. And so what we're trying to take a look at here is sort of how do we get a container that we built, whether this is a demo app or something that you just want to run, and then get that into the cloud. What is the shortest path that you can do to actually get that happening? And so in this case, we have 2 commands that are required to do that. It gets a little bit more complicated because we have a private image that we're using. But if you're not using a private image, if you just need to run like Nginx or something, you don't need to do all the service principal stuff that we did. That's sort of an extra step. And so what this is doing is sort of giving us a way to kind of get the container into Azure, run it in an environment that we're fairly familiar with, and sort of be able to reproduce that as much as we need. I've been drawing a lot of comparisons between this and like Docker Compose. I'm not sure if you should, but that's sort of been how I've been feeling about this. So that is, I guess, that. Yeah, it's been a really fun thing to use. And yeah, speaking of Kubernetes, we're doing Kubernetes next week, kind of talking about how you can run this same application and bring it into Kubernetes and get some of those orchestration benefits that you might have needs for inside of a more complicated cloud. That's sort of, I think, the difference here is container instances are a simpler way of doing things. It allows you to give it a container and run it with a few configuration options to kind of configure resources and ports and things like that. You can also share files if you want to, so you can have a file share that is going to be persistent between the containers. That's something I should mention. If you run this and then stop it, any of your files that are saved, just like if you do this in Docker, if you end up stopping your containers in Docker, that files are going to be lost unless you've saved it. Same thing happens here. So if you need to do that, if you want persistent files, for example, if you're trying to save data files or configuration or something that should stick around, you probably are going to want some sort of persistent file thing. But yeah, Kubernetes stuff. I guess that's sort of, I think, the 2 comparisons I'm drawing. The big thing I've noticed is orchestration. Orchestration is sort of the thing that I think is lacking. There are a few things here that you get, but it's not really, I think, what you want. There's sort of that balancing act I think you have to do when you're designing cloud computing stuff. And this is on one end, and Kubernetes kind of fills that other role. So you kind of have to, when you're choosing one of these 2, I think there's a big question there of how much of that do you need? If you need a lot of configuration and stuff, Kubernetes might help you. But if you just need to run a container, this is the best option that I've found. So keep in mind, I'm still learning. I think we all are. And so yeah, still figuring all of that out. Another thing I should call out. Where is it? Why am I looking for this here? All right, that's silly. Let's just go to here. Go into our resource group. Refresh that. Let's make this a bit bigger so we can actually see what's going on. And if we go into our container instances, we can actually see all of this running and actually get a little bit more information. We have all of our IP addresses. We have our domain name. We have the OS type. That's not configurable. We have where it's running. Oh, that's great. But we also have a few other things, which if I can remember where they are, that's it. Oh no. This wasn't part of it. This came out of the whole Kubernetes discussion. If there's other questions, feel free to drop them and I will get to them. But this is actually kind of important. If I can remember where it is. No. Okay. We'll go back here. So in the setup for this, that is very long. There is a setting for when to restart the image. I guess the best way to demo this is just to do it again. So if we actually go into here, create a demo, let's create a new one. Look at how you can create this from the portal. So everything we did from the console is also possible to do from the Azure portal. So if you just want to create this graphically, it's actually really, really, really nice. So we just do container instances and create this. Click create and actually run through this. Let's select our demo. We'll call this our portal container and set up the regions. It gives you a set of quick start images. So if you just want to grab a really quick image, you can do that. If you want to use something from your container registry, that's available too. There is some additional configuration required that it will walk you through if you want to actually access those. We probably don't have time for that, so we're going to kind of skip that. But if you want to set this up to be able to create them from the portal, that's what you would do. Otherwise, there's also the option for Docker Hub or other registries. So if you have something in GitHub's container registry, maybe an open source project that is publishing images there, or you have something in Docker Hub, and you want to actually pull that image, for example, Nginx, you can specify that here. So if the quick start images aren't what you're looking for and you just need something else, this is a great place to go to grab that. You can also change the size here. And that's everything. We actually should select something. There we go. And then networking, same setup. When we were specifying the port and the DNS name, that's what's happening here. We have our port and we have our DNS name. So let's just call it the SAM Container Demo Portal. I'm bad at names, so we're going to go with that. But you can also select how the networking should work. And then advanced stuff. This is sort of what I was trying to get to, the restart policy. This is something that if you use Docker Compose, you might be familiar with. The restart policy is going to determine when the container is restarted. So there's three options here. There's on failure, always, or never. So never, it's never going to restart. Always, it's always going to restart. On failure means that if there's a failure that causes your image to crash for any reason, this is going to attempt to restart that for you. So what that's going to do is basically relaunch your image for you. So this is sort of a way to kind of recover that if something happens and your app happens to crash. Maybe it throws an exception and errors out. This is going to actually get you back up and running without having to go and rerun all the commands to make sure everything's working. It should just happen. And then tagging, you can do that if you want. And yeah, there we go. There's everything we need to create this. So we can just run this and create our new image. And now we have two different container instances running. Are there any other questions that I have missed? I think the last one was on app services, so we've covered that. Can Azure Container Instances support Sidecar? and support use of Dapper. I don't know. I'm actually in the process of learning Dapper. And so I'm not sure if you can run sidecars. You should be able to. So our demo is very simple and intended to run just one thing. But that isn't how this has to work. And when I was doing this, we didn't necessarily need another set of container instances. When we actually are creating this, we're creating a group. That's kind of a collection of resources that we can distribute between multiple containers. And so inside of this thing, you're going to see this list of containers here. There's just one here because that's all we've specified. You can add more. And so that might be how you would do it if you wanted to do Dapper. But don't take my word on it, please, because I'm still learning Dapper, and that's not a use case that I've explored. So I'm not super familiar with it. But yeah, I think that covers that. All right, is there any other things? Excellent. Looking forward to the K8 session. Awesome, me too. I am also looking forward to that. If not, we can end here, I think. That covers, I think, everything that I wanted to do. I tried to keep this as short as possible, so we kind of got everything working. We can clear this up just by deleting our resource group again. That's probably the best way to do this. I created everything in one resource group. I covered this, I think, at the beginning, but we should cover it again. Typically, with a container registry, you want that in a separate resource group because you're probably going to have multiple different teams accessing that same container registry. You may have one for multiple different resource groups. And so having it all in one might not make sense. So typically, I think you want this in its own separate resource group. But for a demo, so you can easily clean it up afterwards and you don't just keep getting billed for it, this is going to be probably the best way to do that, is just put it all in one, and then you can just delete the entire resource group and you're back to square zero. You don't have any of those resources kind of hanging around for it that you need to wonder if you deleted or anything like that. But yeah, I think that's it. Azure, what is it? What's the command? Azure group delete. And just pass in the demo, and that should delete it. Was there anything I missed? I think so. I think we got everything. Run this. You can set up restart policies, containers, overview. There we go. Also, monitoring is here. So if you want to see how much memory and stuff, that's less useful. Let's go to the one we just created, our demo container. And we can actually see the resources that are being used or consumed by that specific thing. So in this case, we're not even anywhere close to the limits that we set, which is 1.5 gigs of memory and 1 CPU. So we're not even remotely close to that, which is good. That's fine. And there we go. Yeah, I think this is everything that I think we needed to cover here. If there's no other questions, then we can end it here and I can pass it back to Dion.
All right, thank you so much. We can give it a couple minutes and see if we get a few more questions that come in. I know Sam mentioned a few times that this is part of a series, so I will share the link to the series page here in the chat. On the series page, you'll be able to see all of the upcoming sessions and register for those if you would like. You will also, in the next 24 to 48 hours, we'll be able to see the recording for this session if you weren't able to catch the full session or if you wanted to share with someone or rewatch parts. And then about 24 hours after each of the upcoming sessions, you will find the recording on there as well. So it's definitely a handy page to hold on to, and we'll be sharing that during each of the sessions. Let me just check and see if we have any more questions coming in before we go. I want to make sure we get all those answered.
Just to kind of jump in quickly and kind of talk about the journey we're going on in this 4-part series.
That'd be perfect.
this is the first part of sort of how do we get a container from our computer into Azure. The next step we're going to be looking at is getting this into Kubernetes, which is going to allow us to add some orchestration and kind of scale this up and do all sorts of Kubernetes things. And then from there, we're going to be taking a look at automation and figuring out how do we actually integrate this with, say, GitHub and get this pushed automatically. So when we make changes to our code, that ends up in Azure. And then the final thing is going to be looking at state. I've talked about it a few times, but changes or saved data that you try to do in a lot of these applications are not necessarily going to stick around. So if you end up restarting something or rescheduling something in a different place, that data probably isn't going to come with you. And so what we're going to be doing in the final episode is kind of looking at how can you persist data in a database or some other way. And so that's sort of the journey we're looking at, is sort of how do we take a container that we built locally, get it into Azure, and then from there, how do we orchestrate it? How do we make it something that we're actually wanting to run and excited about? And so that's sort of the whole project arc, I guess.
That sounds great. Thank you. Anything else that you want to share before we go?
I think just go and try this yourself. There should be links in the description for this that kind of walk through how to do all of this. And it's pretty fun and not that intimidating. Like, you can just do this on the portal and get something running. And then from there, you can kind of do your own thing and maybe run your own images or do something else. So I would highly recommend just grabbing it and going with it. I think hopefully showed that it was relatively safe. I'm forgetting the word, but not intimidating is hopefully what I'm trying to get at. Anyway.
That sounds great. Thank you so much. And I did share a final link in the chat for the Reactor Survey. If you have a few minutes and can fill that out, it's aka.ms/reactor/survey. It will ask you for an event ID. The event ID for today's session is 14313. All that information is in the chat. We greatly appreciate your feedback. We definitely read over it, and it helps us figure out what people are looking for in the future and what other sessions or series you would be interested in. We also shared some links to our meetup page as well as our Reactor newsletter. So if you're interested in what upcoming sessions we have, please sign up for those and check those out there. And thank you all again for joining us.
Thanks so much.
Bye.